Hi again. So it's a pleasure for the second time this week to open the keynote here. But today is a little different. We have a selection of topics of, well, very recent stuff that has been released or is about to be released. And we'll start with some coverage of the Spring Framework 4.1 release. So within our I/O platform arrangement, we'll actually jump around a little from like the framework at the bottom to XD at the top and so forth. All right. I have been covering quite a bit of the Spring Framework 4.1 stuff in the course of today. So I'm sure some of you have been in the caching and messaging session that I did with Stefan this morning, and the Spring Framework on Java 8 session this afternoon. The Spring Framework 4.1 release is actually out. It's generally available. Went out last Thursday. It was kind of conference-driven, as you may imagine. But it's actually the beginning of a little release train towards the I/O platform 1.1 release. So there's a boot 1.2 and a couple of other releases going along with Spring Framework 4.1, culminating in the I/O platform release 1.1 in November. So what's in Spring Framework 4.1? Quite a bit. The annotated JMS method story has been covered in detail this morning. I'm going to show you just an impression, an example in a minute. This is something we've meant to do for a long, long time. I mean, to some degree, we always have plans, always have priorities to set, and some things we just don't get to. And we took the opportunity here to go really comprehensive with it. The annotated JMS listener model in Spring Framework 4.1 is a pretty recent kind of rethinking of what we wanted to achieve there, based on the Spring Framework 4 messaging module. So we actually have some recent innovation, some recent consolidation in that space that we are building upon. Similar story applies to the JCache annotation support that we have. Spring, of course, introduced cache annotation support in Spring 3.1 a couple of years ago. The JCache specification, we have been tracking it for a number of years. Some of you may be aware that we've been shipping early JCache support even in the Spring Framework 3 line. However, the spec took a while. It went final this April. So Spring Framework 4.1 for us is the opportunity to support the spec as it has been finalized a couple of months ago, and to ship support for its annotation-based model, its declarative caching model, next to Spring's own caching annotations. Those nicely coexist, as I've elaborated this morning. Aside from JMS and JCache, there's a strong focus on web and WebMVC improvements in 4.1. And a lot of it is being covered in dedicated sessions. I'll be mentioning one at this conference. There's in particular a focus on the management of static web resources, flexible resolution, transformation of static web resources. Something we meant to do again for quite a while. We've had a basic infrastructure in that space, but we are really taking it to another level in the 4.1 generation here. There's quite a bit of stuff in the MVC view space. I'll be covering a bit of that as well. I'll explain that best with an example. There's other stuff, groovy markup templates, support for Jackson's JSON view mechanism. There is a lot to discover in the 4.1 release, just in the WebMVC, web view space. Of course, we introduced WebSocket support in the Spring Framework 4.0 generation, and 4.1 is an opportunity for us to do a revision, an update, and refinements in that space. So there's quite a bit of stuff. There's a WebSocket scope, a SockJS client infrastructure. There's a WebSocket statistics mechanism. There's a lot of practical feedback that has been incorporated back into the framework. The WebSocket support is actually a great example of new functionality which got immediately adopted the moment that we released it. We were actually surprised and impressed with the level of feedback that we got. So thanks everyone. There's really a great deal of practical feedback that we are able to get back into the framework. And we did that, of course, in the 4.0x releases. We're always doing those things very immediately, as soon as we can. But some of the things we had to wait for a 4.1 release. Some of the things have a little impact in terms of configuration, may have a little impact in terms of the runtime log output and so forth. So we are waiting for a proper minor generation of the framework before we make those sorts of changes. And there is a kind of performance topic in 4.1. Performance is, of course, always, a topic. But we have a pretty interesting mode in the spell infrastructure in Spring, where we have a compiler mode now. So the Spring expression language can be, interpreted with on-the-fly compilation, where some of those expressions identify themselves as compilable and can be turned into a bytecode representation that we invoke whenever that expression gets evaluated. This is particularly interesting for hotspot expressions that are really on a code path that is being hit very often, such as in message routing scenarios and so forth. So this is pretty cool stuff, but it's not the only thing we've been doing in that space. There's a lot of concurrency fine-tuning, an ongoing story for a number of years now, but 4.1 is really going yet another step in making the container as concurrency friendly as possible, minimize the amount of logging wherever possible, and choose wise trade-offs wherever possible. So that's a lot of stuff actually for a 4.1 release, more than we usually do. And the iteration is actually short. Keep in mind 4.0 went GA last December, this went GA last week, about 9 months in between. So we have a pretty intense development phase at this point, and I expect that to continue for a while. All right, a couple of examples, a couple of impressions. More of that has been shown in other sessions or will be shown in other sessions still. The annotated JMS listener story is basically as you would expect it to be. We have been establishing principles for how the endpoint style, an annotated endpoint style, typically looks like in the Spring world, and the JMS listener model here is basically exactly a translation of those principles, of those design styles to the JMS world. It builds on the messaging module, so it's also very similar to the Stomp endpoint model that we introduced in Spring 4.0. It's also based on the messaging module. And can do all sorts of nice little things. Also looks like Spring MVC, of course, while we're at it. So a Spring MVC handler endpoint model, of course, has been pretty much the first in that line, setting that style really up for all the other parts of Spring. All right, so that's basically annotated methods indicating a certain binding to a specific JMS destination, can flag all sorts of special things at that point. But the interesting part is the method signature. You get what you declare, so it's a very flexible signature. You can ask for a pre-converted payload object to be passed in. You can ask for a message to be passed in, a message representation, the JMS message, or a Spring messaging message. You can ask for specific headers to be passed in, or for a headers map to be passed in. Like with Spring MVC, we react to your declared endpoint signature. So that's pretty nice, and actually a pretty nice application of those principles. Makes a lot of sense, in particular in applications with lots of messaging endpoints, where you don't want to implement a message listener type for each of those endpoints, rather a method where the granularity of the method-based model is a much better fit. Right. An impression of the JCache support. It basically looks like the Spring messages. I mean, the Spring caching annotations. The Spring caching annotations have been an inspiration for the spec, so it's not exactly a surprise. But nevertheless, the end result in JSR 107 is it's also different in quite a few ways. They opted for different compromises, for different trade-offs. The way that, for example, relevant parameters that are relevant for the key, how those are being identified is a little different with this add cache key annotation that is shown here, where in Spring you would rather have a spell expression that identifies those attributes or that computes the key from those attributes. There's different naming. In Spring we have add cacheable. This is add cache result, basically the same thing, an equivalent annotation. There's other ones, there's add cache remove. In Spring it's called add cache evict. So some naming differences, but it's a pretty analogous model. Easy enough to translate your code to if you choose so. We support this side by side. It's worth noting that those models do not replace each other. They complement each other. They can be used next to each other within the same application. We auto-detect the presence of JSR 107 the moment that you activate the processing of cache annotations in Spring and you have the JCache API on your class path. That moment you'll get full support for this model, auto-detected when you start using those annotations in your component classes. All right, a couple of additional words on the web resource handling. Well, first of all, there's a dedicated session tomorrow morning and a showcase app that we did, that Brian did. Check them out, both of them, definitely. But the web resource handling story is a very practical affair. It is about the resolution chain and the transformation chain that you apply to static web resources. For all sorts of things, caching strategies, compression arrangements, versioning of resources. Those sorts of things can easily be expressed as either a resolver or a transformer within that infrastructure. And we ship quite a bit of stuff out of the box. This is one of the biggest revisions actually in the MVC space in a while. The Spring Framework 4.0 release was focused on WebSockets and many things, but not exactly on fundamental features in Spring MVC. 4.1 has different priorities, a strong investment in MVC, and this is a great example. This is also a good example in the configuration story for Spring MVC, where this is a 4.1 mechanism allowing you to express view resolver setup in a nice, convenient way, both as an XML namespace and in the form of a configuration class here with the view resolver registry, builder style APIs, setting up rules for the view resolution chain, for the content negotiation, and so forth. So a pretty nice arrangement, in particular for modern day web applications which happen to use several view technologies within the same app. Right, and just dropping a few points your way for other stuff to check out. This is by no means everything in 4.1. There's plenty of other stuff. That we had the major themes initially mentioned, but we ended up doing a lot of other stuff as well while we've been at it. So basically everything on here, those are issues that we ran into, that we bumped into in the course of developing Spring Framework 4.1, in the course of working on the feature themes. And those are things that we kind of did along the way, that we picked up because they got many votes in Jira, they got many votes on the issue tracker, because they just made sense next to other stuff that we've been working on, or because we got an interesting proposal and it was easy enough to still add to the release. That's how we always operate. So if you send suggestions, improvement requests our way, some of them are going to be dealt with very quickly, in particular if we are already in the middle of it, preparing for the release candidate phase, as we've been in the 4.1 case. Some of those things are particularly interesting to pick up right before a release because we're trying to get as much as possible into it. Anyway, so we have finally have some direct field binding support for nested properties and some autograying for nested properties. We have support for Java util optional, the Java 8 optional type, 4 injection points for handler method arguments. We support the new standard javax.annotation.priority annotation for dependency ordering and the selection of primary candidates. We have an annotated model for lookup methods now. The good old XML-based lookup methods, XML-configured lookup methods, now have an annotation equivalent in the form of @lookup, including support for method arguments. So lookup methods being called with declared arguments are going to see those arguments passed on to the target bean as constructor or factory method arguments, like a get bean call with arguments. So it's actually a pretty nice addition to the model, in particular for more demanding retrieval or lookup arrangements. We have some interesting enhancements in the test context framework, for example, support for declarative SQL scripts, support for programmatic demarcation of transactions in a revised style. And, well, in our mission to react to highly voted issues, we've also been picking up some Hibernate issues, some Hibernate configuration issues. There are some very common demand in the Hibernate JPA case. So with Hibernate Entity Manager as a backend for Spring's JPA support. So in this world, we're finally supporting isolation levels. We auto-detect managed packages with Hibernate annotations on those package info classes, and a couple of other things. So those are things that we rolled into it and that are also available in the Spring Framework 4.1 GA release as released last Thursday. All right, so much for a little bit of coverage of 4.1 and some maybe a little bit of insight in how we actually select the stuff that goes into such a release. Well, next up is Spring XD. Also having seen its GA release not that long ago. So we have Mark Fisher to come up on stage. Oh, there you are.
Thank you.
All right, enjoy.
I guess this. Okay, so as Jay mentioned, this is actually the 10th year of Spring 1, or what was originally known as the Spring Experience in those first few years. Also happens to be my 10th year at this conference. I joined the company a few weeks before the Spring Experience 2005. And one of the things I like to do every year is kind of look back on what we were talking about last year, how well did we see what was on the horizon, and prioritize where we needed to be. And looking at last year in particular, we had Boot and XD both in milestone phase. We had the I/O website went live at the conference. The I/O platform itself was slideware, basically. And that's also achieved 1.0 status in the past year. So it's a pretty interesting time, and I think last night Andy Glover really gave us a perspective that went all the way back to that first conference 10 years ago at the what the ecosystem was like at the time. And so it really made me think a lot about the future, but I think what I took away most from what Andy said is that where we are today is actually as interesting a point as we've been, I think, since that 10 years ago when we were focused on providing a simpler model compared to EJB. And so after me tonight, you're actually going to hear a lot about the really interesting things that we're looking at on our horizon now with reactive streams and microservices and all of that. So this kind of reminded me of a joke I heard just a couple weeks ago. It was the past, the present, and the future walked into a bar, and it was tense. Okay, so with that, just testing the waters to see if I can change my career to stand-up comedy, but I don't see it happening. So tonight I'm actually going to focus mostly on the present. I'm going to show you where we are with Spring XD. So some of you have probably seen this slide. If you were in the sessions earlier today, this is kind of the big picture view of what Spring XD is. And I should mention on the previous slide, we say big data, little time. What does that mean? Well, like with everything in Spring, we're trying to make life as simple as it can be. And when you're building a big data application, there are a lot of pieces. And that's what Spring XD is really trying to help you so that you don't have to build all of the pieces yourself. There's a unified platform that can handle big data use cases. So big data use cases typically require some kind of ingestion of data. That data may be coming from users on mobile devices. It may be coming from the Internet of Things through sensor data. It may be coming from files and logs from your system as it's running in real time. And that data is typically going to be ingested somewhere like HDFS, largely distributed storage. Once you have the data in HDFS, you need to do some batch processing on that. And as it's being ingested, you might want to do some stream processing on that. And then there's closing the loop between what you do with the results of your batch processing. So the demo that I'm going to show tonight is actually an example that really highlights all of these points. It's going to be taking sample data and generating a model from that to be able to predict the energy consumption requirements of a smart grid. So then the real-time ingestion is the smart grid data. The exported model in PMML is then also going to be used on the real-time data that's being streamed in to predict the short-term forecast load requirements. Okay, so Spring XD, as I mentioned, reached GA about a month ago. And I just wanted to highlight a couple of the main features that we've got in the GA release. So starting around milestone 6, a few months back, we actually adapted our runtime to be based on Zookeeper. Before that, it was a messaging middleware kind of solution. But we didn't have the same, we didn't have basically the state of the cluster in that model, and we didn't really have the failover capabilities that we needed. So we build on top of Zookeeper, and we actually build on top of the Curator higher level API, which is a Netflix open source project. And we use the primitives that Curator provides, for instance, the leader election for our admin nodes in XD. So you can have multiple admin nodes, and they can all serve the REST API, and you can put a load balancer in front of them so that you can scale. But one of those admin nodes will be elected leader, and that's the sole admin playing the role of a deployment supervisor to manage the deployment of streams and jobs across the cluster of containers. Likewise, when containers depart the cluster, then the admin will be notified because of the Zookeeper nodes that disappear when a container disappears. And then the admin that is in the role of supervisor will redeploy modules that were on that failed container or that departed container onto other containers within the cluster. And then we have the deployment, the basic ability to customize the deployment of your streams and jobs, where you can target individual containers or containers that belong to a certain group or any criteria that you can specify that is evaluated with the spell expression. You can specify the number of instances that you want. So you'll see that in the demo tonight. I'll run a few instances of the source and a few instances of the sink. And you can also do data partitioning when you deploy by specifying the properties that you want to use on the data as it's crossing over those multiple distributed nodes. And again, that relies on spell. So with Spring 4.1 improvements on spell, that's going to be a major factor because it's part of the runtime critical path with XD. So that's really exciting for us. Another feature is the ability to have direct binding between modules that happen to be co-located on a container, and you can actually control that to a degree so that you have co-located modules avoiding extra network I/O. The demo that I'm going to be showing tonight is based on, as I mentioned, smart grid data that happens to come from a grand challenge of the ACM this year. It's real data from 40 houses in Germany. And in those houses, there were these smart plug devices. As you can see on the right-hand side, there's basically certain fields in the data that represent the load, the actual real-time load at that moment, and the timestamp. And then there's the house ID, and within a house you can have multiple households, and within a household you can have multiple plugs. So on the left-hand side here you see an example of what that data looks like. It comes in a large CSV file zip that we have used on our demo. And basically what we're doing is if you think back on the diagram that I showed just a minute ago, we're doing ingestion, we're building a predictive model, and we're using that on the stream data that's being processed in real time from the actual load. So we end up with 3 streams here. There's the main ingestion stream, which goes from HTTP to HDFS, so as if the sensor data is coming in over HTTP. Then we have a stream for counting, and basically what that means is that it's taking the load, and it's keeping a sum of the load and the averaging. And that's happening on buckets of every minute. The count, so that is actually being determined on a per house basis. So we can split that up with a field value type counter. And then for the prediction stream, what we're doing is we're actually taking the data as it's being ingested. We're running it through a PMML module that XD provides that's able to delegate to a PMML model that we generated offline with training on a subset of this data. And then that PMML adds the score, basically the prediction of the value for load at this current time for that particular house. And then we can compare that in a UI. Okay, so the topology of this deployment, we're going to be running this on EC2. And we basically have our XD cluster. So we have the XD admin, we have multiple XD containers, we have a zookeeper ensemble, and we have Rabbit as our transport for the message bus, and we have Redis for the data that's being stored for those counters. And then we're ingesting into a Pivotal HD cluster of 5 nodes. And for the simulating the sensor data, we actually are using JMeter in the front as a generator. And then that's going through the Elastic Load Balancer on EC2, where all of our HTTP containers have been registered. Okay, and so with that, I'll go straight to the demo. Okay, so I wanted to begin with the kind of walking you through that topology that you just saw. So here in EC2, you can see we have the smart grid containers. I have my XD admin, and I have, I think, 9 containers. And we've actually started these up so that they belong to 3 groups. There's an HDFS group, an HTTP group, and then a TAP group for the counters. So there's 3 groups of 3. We also have the supporting infrastructure here on the cluster, not that. So we have our zookeeper ensemble with 3 nodes. We have Rabbit, and we have Redis. And then we have the PhD cluster. So I'm just showing you all the actual nodes on EC2 that are relevant here. So that's a 5-node deployment. Okay. And then I want to switch to the UI for XD. So this shows the container view for this cluster. And you can see the unique IDs of our containers. You can see the group that they belong in. So as I mentioned, we have 3 in the HDFS group, 3 in the TAP group, and 3 in the HTTP group. Right now, I'm currently running the TAPs already. Those are already deployed. What I'm going to do is I'm going to deploy the ingestion stream. So here you get the streams view. And it's probably not that easy to read, but basically the one that is relevant right now is this HTTP to HDFS. That's what I want to deploy. And then this brings me up the UI for adding the deployment properties. So as I mentioned on that slide with the configuration of where your module ends up, we can specify we want to have 2 instances of the HTTP module. We want that to go to containers that are in the HTTP group. And we want to do partitioning on the house ID. So the payload is the actual data object. And we have a house, and we're going to just have it basically hash the string value of that house. And then we're going to have 3 instances of the HDFS sync. So this will be a mod 3 partition on the value from that key. And we'll put those on nodes that belong to the HDFS group. Okay, and we see here the state is deploying, and hopefully will be deployed. Okay, and so now it's deployed. We go back to the container view, and we can see we ended up with the ingestion stream being deployed across those other containers. So we have 2 HTTP source modules and 3 HDFS syncs. Okay. And now I'm going to kick off the JMeter load. So we also have another node on EC2 where JMeter is running. Oh, before I run this, actually, I just want to show you the data is sitting here. So this is the house data that you saw depicted on the slide. So we have the ID of the entry, we have the timestamp, we have the load, we have the house ID, the household ID, and the plug ID here, and the type of data. And then I also wanted to show you the properties that we're using. So you can see that with JMeter, we're basically running it headless. We're pointing to that CSV file. This is the Grand Challenge house data, and we're pointing to the load balancer that we have on our EC2 cluster. And those HTTP modules are bound to that. Okay, so with that, I will generate load, and that starts running, sending through our load balancer from that data file. And now we're going to look at Rabbit. So you can see Rabbit, we see the activity here. This is our bus. So these are the queues that were created in Rabbit. You see there's 3 for ingestion because we're partitioning 3 ways. You can see down here the activity, and you can see down here the 2 tap. These are anonymous connections generated on a fan-out exchange for the taps, and then the prediction module that sits between the PMML module and the actual counter there. And then this is in HDFS. So I refresh this, and now I have ingest. And again, you see 3 partitions of data being written to HDFS. And then finally, I want to show, so you get a sense of all the moving pieces here. I'll log into our Redis instance that I showed earlier, supporting this cluster. And we'll go into the CLI. And I'm just going to list the keys so that you can see that these are the buckets. So we have aggregate counters. That's the XD prefix. This is the prefix that is being used in the, we have actual and predicted per house, and then the time buckets that are generated by XD. So this rolls up to the minute, to the hour, and to the day, and all the way up to the year. And now the UI that we built on top of this is actually interacting with the xd-lms REST API just to get this counter data. So that's the only entry point from the UI. And then it's putting it together into a view. Okay, so one more thing I wanted to do is exactly that. Go start the... So I'm logging into the admin node, and there we have this UI, which is actually a boot app. So as you heard last night, and we'll continue to hear tonight, I think the boot is on a quest for world domination. It's definitely taken over us as well. So let me just make sure I got my right environment set up. And I'll do Maven Spring Boot run. Okay. And now we go to the UI. And we can see the blue line is the actual data that's being ingested. The orange line is the prediction values that are being retrieved by that PMML module in real time based on the training set model that was generated on that data. This is actually showing the full grid. I can also drill down to the individual houses, and we tend to test with house 28. I think it has the highest load. Our y-axis actually scales with the amount of data, so you can see here it's pretty high load, and you can see the prediction. Obviously, the actual data is fluctuates more than the prediction values. A couple other houses that are interesting. I should mention over here on the left-hand side, we've got the total kilowatts right now, so that's actually aggregating the values from the last minute. And then we have 40 houses, 343 total households, and 2,125 plugs. Let me show you, I think house 11 was one. It's kind of interesting. So there are different things. Obviously, there's different patterns, and what we would typically do in an app like this is actually close the loop even more so that we're taking the real-time data and continuously enhancing our model and comparing our model to the data and making that more and more refined as we get more data. And then house 30, I think, has another different shape, yeah. So you can see the different data for different houses. And some map better to the prediction than others. So I guess some people are following more regular patterns in their day-to-day life. Okay, so let's go back to the container view, and I'm going to do just one last thing here while I'm in the demo, just because it's not a good demo if something doesn't go wrong. So I'm just going to push it a little bit here. Basically, we have all these containers running. As you notice, the one on the bottom is in the HTTP group, but it doesn't have an instance. If you noticed when I did the deployment, I had 2 HTTP instances and 3 HDFS instances, but I had 3 containers for each group. And the reason I did that is to leave myself some headroom so that I could demo a failover. So watch the one on the bottom. What I'm going to do is actually shut down one of the nodes that does have HTTP installed. Okay, so you can see here, and these are average message rates, by the way, that we're getting from Jalokia endpoints, another thing we get from boot. So we get that from boot. We also get this endpoint to shut the container down from boot as well. And that's just the stuff you see on the surface. Okay, so I'll shut this down, and then our container view should refresh. And now you'll notice that our other HTTP module at the bottom has picked this up. So that automatically failed over. If I shut down another instance now, it's actually going to update the status of that stream to yellow, which indicates that it's incomplete. And incomplete means that I only have one HTTP source, but I requested 2. If I bring up another container, then it would go back to green. And if I shut down another container from HTTP, it should go to red, which means it's actually failed and cannot process data anymore because it's missing at least one instance of one of its components. Okay. So I think that's it for the demo, and then I've just got a couple more slides here. Let's see. I can find my remote. Okay, so a little bit about where we're going, and I think especially relevant for what you're going to see later tonight. One of the things that we're going to try to do is further unify the batch and streaming models within Spring XD. So we're using Spring Batch for the batch processing. We're using Spring integration for all of the streaming. And we do have, at the DSL level, a pretty consistent experience. At the admin UI level, a pretty consistent experience. I think it's an improvement for people who have used batch and integration together in the past. XD is wrapping all of that up for them in a way that's much nicer. We also have communication between the two. We talked about this a little bit in our session today, where batch jobs are actually launched by sending a message to a channel. And you can also tap a batch job to create input for a stream. So there's this bidirectional communication between them. But we want to take that further in the DSL level and actually modularize batches down to where you have readers and writers kind of corresponding to sources and sinks in our stream model. And somewhat related to that is we're going to be building upon the Reactive Streams API within Reactor that you're going to hear a little bit more about from John in just a few minutes. And that's going to actually give us even more capabilities where basically we can span from what we have in item-at-a-time processing with the streaming approach today to full batch processing, like long-running jobs and MapReduce jobs that run on an hourly basis with Spring Batch. That gives us something that really fills in the spectrum, allows us to do micro-batching, and allows us to do windowing. So you'll have all kinds of streaming operations available within XD to do time window averaging, to do joins, joining streaming data with historical data, being able to do MapReduce and streaming MapReduce, and all of those kinds of operations, and also giving you access to the API directly, so that you'll be able to drop a module in that has the Groovy API for working with the stream, and then that becomes an XD module that may coexist alongside the out-of-the-box sources and sinks. So you can do HTTP pipe and then write your own Groovy script that uses the Reactor API. So that's going to be, I think, one of the most exciting things that we're working on at the programming model level. Also, for the developer experience, we're going to be working on support for Java config, support for the Spring integration DSLs. There's been a lot of progress there, especially on the Java 8-based Spring integration DSL. And we also have Groovy and Scala DSLs. So this would be a completely XML-free experience when you're writing custom modules. And then we're going to be using boot even more. So XD uses boot itself as the runtime, but we're going to do more with boot for the end user that's providing custom modules, so that you basically have a starting point that is much simpler than what it would be today. And then from a deployment perspective, we're working with the Cloud Foundry team, and we actually have XD running as a Cloud Foundry service. We have XD running as Docker containers, and we also have a prototype of a Mesos managed cluster for XD as well. So all of those I think are going to be interesting. And we had 2 sessions today that if you missed them, unfortunately they were 2 of the best sessions of the conference. But those were 2:30 and 4:30. So overview of XD and then the deep dive that David and Patrick did after that. But we do have 2 sessions tomorrow and 2 sessions on Thursday. So you can come see Michael Manella talk about a recommendation engine built with XD. The connected car, you definitely don't want to miss that one. There is actually a real car involved. And then Spring XD for real-time Hadoop workload analysis on Thursday, and then implementing the Lambda architecture with Spring XD, which we gave a little bit of a glimpse of that perspective today in our talk. So that's Thursday at 12:45. Okay, and with that, I think Dave is up.
Great job, Mark. Thanks. I really get a kick out of seeing the node die and then stream comes back. I think it was just fantastic. I love that demo. So well done, you guys. For me, that's a really good example of a huge, even the smallest demo has got quite a lot of moving parts in it, right? And that's why I'm here tonight, to tell you about what we're thinking about along those lines, right? How can we help? Now we've got lots of experience with it hands-on, frankly. How can we help people to build that kind of system again, right? And how, what lessons have we learned, and what can we feed back to people, and what can we share? So I showed you this picture last night already, and I'll just recap it, right? So you've got the the I/O distribution, which is fantastically useful, tying everything together, Grails, joining the party, it's all very excellent. I was going to wear my Grails t-shirt tonight, actually, I forgot. I apologize. I was going to say, since I wrote some of the code in Grails now, I should be able to wear the t-shirt, and I forgot to put it on, but never mind. I'll wear it tomorrow. It's all there, but, okay, this is what I said last night, when you start building these little apps, and deploying them into not just, standalone systems that just do things on their own. When they start to have to coordinate, you need something else. And that's what we've decided to call or rebrand Spring Cloud. Okay, so that's what this section is about, this section of the presentation. And so yesterday I said microservices are not a free lunch. So I think somebody else said that. So this is an attempt at being original. But paraphrasing, I don't know who it is, Swift or somebody, no man is an island. Well, no microservice is an island either, right? You don't just sit there and, don't interact with anything. So that's what we're trying to do now. We're trying to lift the level of focus of which patterns, which problems we're trying to solve, to a slightly higher level with Spring Cloud. Not to say that we don't need to solve the low-level problems as well, but we're starting to just sort of change the focus a little bit. And so what it says on the slide, right? I mean, it's really nice, it's excellent that you can use Spring Boot and you can get a tweetable service that really is micro. It's almost nano, right? You can run something really meaningful in quite a significantly small amount of code and make it do something real in production. But there are just some things that you can't do if you're going to deploy even two of the same thing, right? 2 things with the same role. They're going to have to coordinate in some way, probably share session data, whatever. And then when you add more layers, like we just saw in the XD demo, there's like, I don't know how many there were, 5, 6 different roles in that system, multiple instances of each one. They can't just, take care of themselves. They need to be coordinated. There are actual laws of physics that mean that you can't, make a system that runs smoothly without some help, some coordination. There's laws of physics, and there's also laws of, I guess, developer dynamics, right? We, as people who are developing these systems, we are going to go mad, and we're going to tear our hair out. I speak from, obviously personal experience. If we have to develop these systems without help, if we don't think about this, we're going to, lose the momentum, basically. We've got a nice bit of flow going on now, so let's not ebb. Let's keep pushing on and start using some sensible approaches to these kinds of problems. So what I'm calling, these are the problems, basically. That once you start gluing things together, gluing services together, things start happening. So I'm calling that an emergent feature. Behaviors happen that you didn't predict. And until you start doing it, you won't know what I mean. But as soon as you do it, you will know exactly what I mean. So these are the kind of problems that we've identified as boilerplate, right? These are things that people do over and over again. We've got a list of about 30 of them now. So this is a sort of highlight. Configuration management in the sort of Spring environment sense, right? I can speak to this audience and everybody knows what I mean by that. Property sources, like property files in your jar file or locally, but actually centrally managed. That's configuration management for me. Configuration management means something different to other people, unfortunately. But service registration, okay? So I think somebody I know called, was it Adrian Collier, said 3 things you need to know about services: how to deploy them, how to discover them, and how to bind to them. And so the discovery and binding is really what we're doing in the second bullet. How to build them, we already did that. Actually, he didn't say how to build them, did he? He said how to deploy them. Deploying them is Cloud Foundry. Building them is Spring Boot. Deploying them is Cloud Foundry. Registering and discovering is something I'm going to show you in a minute. I think there's going to be more than one way to do that, incidentally, but I'll show you an answer to that. Other things as well: intelligent routing, service-to-service calls, load balancing, circuit breaker, something I'm going to focus on in a minute as well. Everything needs to be asynchronous, non-blocking, all of that stuff. So John's coming up next to show you the amazing stuff that he's been doing. And some glue to coordinate everything together at the sort of messaging level, right? And what we want is strategies for that. And we want to give developers, you guys, the power to implement this stuff in the way that you like, the way that you want it to work, but with the absolute minimum amount of fuss, right? That's what Spring Boot is about. Get it done quickly. So here's the layer cake, which I said I wasn't very happy with yesterday. I'm still not, but it's in a box, so you can see it, right? That thing at the top right, the coordination layer, sort of expands out into probably more than this, but these are the highlights that we've identified, I guess, for the sort of initial wave of effort that we've put into the Spring Cloud. So an event bus at the bottom, maybe tying things together. If you change configuration centrally, then you want everybody to know about it. You need to broadcast that kind of information. There's all sorts of things an event bus can do. Hopefully lightweight and as optional as possible, as with all of these things. Along the top, sort of top middle bit, you've got service discovery that I mentioned, configuration server, and circuit breakers, and I'm going to focus mainly on that stuff, I think, at the minute. Edge service, I think of as being sort of, rate limiting, security concerns, things that, you protect the inner environment of backend services by putting an edge on the internet-facing or the corporate internet-facing edge of your system. Probably don't need to talk about all of these things in any detail, but just look at the bottom, right? Global locks, cluster state, one-time tokens, leader election. Those are all things that Mark's been talking about. So we're going to have a great time collaborating with the XD team as soon as they've got their head out of 1.0, basically, in Spring 1. And so we're hoping that that end of the diagram is going to be filled in by work that we've basically already done in Spring XD. The rest of it is basically what I'm going to demo now. So, as soon as I know that it's there. I'm not cool, so I don't use black screens with white letters. Hope that's all right. Mark's even got a black and white hoodie on. He's the cool kid. But I do have a terminal, look, at least. Anyway, so where am I? I've got this demo. This is on GitHub, by the way. It's in the demo lounge as well. I saw it on the screen today, so somebody's already been playing with it. You can find a domain to do with customers and stores and a UI to do with that as well. I'm going to Spring run it. It's a little Spring Boot CLI app with an Angular JavaScript backend done by Gunnar Hillett from the XD team. He did a bang-up job on it, and so I need to make sure that he's adequately rewarded. Buy Gunnar a beer next time you see him. Raise your hand, Gunnar Hillett. Can't even say, I can't see anything from up here, frankly. He could be there or not. There's the Spring Cloud website, by the way. It's just part of spring.io, right? projects.spring.io/Spring Cloud, list of stuff, quick start, sub-projects, things that we're working on. So that UI just came up, and here it is. It's nice, you know, touchy-feely, front-endy stuff. It's got customers, it's got stores, it's got a big diagram of what I'm going to show, which is, I find, quite useful, and hopefully you will, to understand what's going to happen. So what we've got here is the components in the system that I'm going to deploy. I'm not going to rely on the network and try and do it all on Cloud Foundry. I'm going to do it locally, but it is running on Cloud Foundry, and maybe I'll have time, hopefully, to show you what the URLs are so that you can ping it with your phones and make sure that it actually does what I'm telling you. So I've got this thing. This is the UI at the front. It's an Angular front end with a very, very thin server backend, basically, which is just a proxy to backend services, customers and stores, and that's convenient for a number of reasons, including cause protection. So the main sort of business logic here is in these two services, and they also interestingly have a link between them, if you notice that. So customers, if the store's app is available, if the store's service is available, the customers will be able to locate stores around them. So I'm just going to be, the UI is going to be a nice one with maps and pictures of Starbucks shops and stuff like that in it. But that all depends on the fact that these two things can connect to each other. How are they going to connect to each other? They're going to ask the service discovery component, the registry. So customers are going to register with service discovery, stores are going to register, and then customers are going to say, hey, service discovery, give me some stores. And hopefully service discovery will say, sure, here's one, try that. If you don't like it, come back and get another one. There's that kind of pattern. At the same time, there's some redundancy, there's some resiliency built into it. So there's a circuit breaker. This is a really, really key concept if you're building this kind of system. We want the whole thing, the whole system to continue working. If the stores are unavailable, we don't want the whole thing to die. In fact, this app is running now, right? It's not dying, and the customers and stores aren't even there yet. Nothing's there yet, just the UI. It will also work if I just run the stores, and that's what I'm going to demo later on. And that is implemented using a very important circuit breaker pattern. It's not just a retry where if it fails, it falls back to something else. It's a bit smarter than that. If it fails, it's got rate limiting thresholds. It's an electrical circuit analogy. The circuit starts closed when everything's working. It's fine. If there's a failure and it passes the rate threshold for failures, 20 failures in 5 seconds, I think it is, the circuit will break, and customers will then no longer even try to contact stores. The circuit is broken. It's in a different state than if it's closed. And that stops downstream systems from being flooded with useless requests, And that's a really, really useful tool. And there's a great thing at the bottom of the stack here. There's a UI that you can use to monitor that. And that's the punchline basically is all this stuff has been, not all, but a lot of this stuff we've implemented using Netflix OSS stack. And this in particular is a UI that has got absolutely no Spring branding in it at the minute. It's just the dashboard that they provide from Netflix. And they use it all the time. All the time. You'll see why when I show it to you. Hopefully I'll get that far. On the left-hand side is almost the most important thing. You can't really do anything without a config server because it's going to tell everything else where the other things are. So this is kind of bedrock. When you run it in Cloud Foundry, that's the most important thing. Running it locally, you can sort of default everything so that it kind of convention over configuration. Again, it all makes sense. Right, so the first thing I'm going to show before I start anything else is just to make sure that this is a Spring Boot app. I'll show you it has an info endpoint. Disappointingly empty, I would say. All right, so nothing there. Guess what's going to happen? I'm going to start the config server. I've got enormous font size here, and yet I can fit the whole application in one editor screen. That's it, basically, at enable config server and some configuration. So we figure this is a nice tool. You can run it really quickly and get something working with no effort, and then you can configure it using application.yaml, and then you can extend it using various extension points. I'm just going to run it. Run the config server. I'm actually going to run the discovery service as well, which is Eureka. Also similarly tiny. It's got Gunner's name on it, but it didn't take him very long to write that, did it? That's it, basically. That's the Eureka server. So these actually can be run as Groovy scripts pretty easily as well. And I'll run the Hystrix dashboard as well when I'm here. Another one, at enable is Hystrix dashboard. This one's got a little bit more just because I've given it a home page. It's an embeddable app, so normally it lives in /Hystrix/, but for this demo, I just want it to be on the home page, so I just added that. What else can I do? I can start the customers. This is Ollie Gierke's customers and stores, so it's got a little bit more in it. The interesting thing here from the distributed Spring Cloud stuff is at enable Hystrix. So that's our annotation, but we're just wrapping Netflix features for circuit breakers. So that's the customers. I'll show you the details of that in a minute. And the stores there. Stores is another Spring Boot app, basically. It's a Eureka client, importantly, because it has to register with the discovery service so that the customers can discover it. Where's that gone? Store app. There is actually missing from the diagram here. There's a Mongo database sitting underneath the stores, and there's a rabbit doing event bus things, which I'm not going to show today, but if you come to Spencer's talk that I'll be at tomorrow afternoon, I think it's at 2:30, we'll be going into a lot more detail on all the stuff, and you'll be seeing all the features. So now, well, definitely the config server is running. Do we think we have info? Not yet. Why not? Because nobody told the poor thing that there was anything. So let me see if I can fix that. So localhost, it's 9900, isn't it? /refresh. I just need to post something, so I'll post anything. And, hey, look, it's picked up something new. So let's see if the info endpoint works, right? So that's a new feature. It's a bit like the logging change that I did last night, but it's a little bit deeper. I'll show you the details tomorrow if you come and see it. It's very cool, and I'm sure it's going to be very useful. We've got restart, pause, and resume as well. We've got various new endpoints there. So what's next? Right, let's see if we can actually operate this UI. It's gone into mobile mode because I've made the font size so small. Okay, here we go. So I can add a customer. I can, sorry, first I have to get the location, populate the address. I'm really glad that Gunnar did this because I can't remember my latitude and longitude to save my life. I don't know what it is about me. Does anybody have that experience? Okay, so there we go. I'm in Dallas. I can look at myself on a map. Starbucks, right? There's 1 there, there's 4 there, there's 3 there. Another big round of applause for Gunnar, please. So that's cool. That's cool. It's all working, which means that everything I just started worked. That's worth a round of applause on its own. So now I'm going to look at Hystrix, the dashboard for Hystrix. I'm going to go 7979. I did start that. Yeah, here it is. It's just a big font. Okay, so the way this works is it's going to, I'm going to give it sorry, 9,000 is where the customers are running. So I'm going to tell it where to find a server-side event stream. All right, so we've installed that. When I did @enable Hystrix, I installed this stream, basically, on the customers. And so I'm going to monitor that stream in nice big fonts. Hopefully you can see that. So there's a method in there called getStoresByLocationLink, right? So the customers are going to try and find stores. Nothing's happened recently, all zeros. What's the best way to do this? The best way to do this is to have the browsers side by side. So if I go back to customers, look at myself again, okay, and then I start hitting that, refreshing. You can see every time I refresh, I get a nice green light saying that the stores are available, this is fine. So the interesting thing to do is to go into the Stores app and shoot it in the head, and then go back and do the same thing again. Now it's failing, all right? Red failures. How many can I do, right? I can do a few. It's a little bit tolerant of failure, but it won't tolerate higher rates of failure. That's why it's got a moving graph, because it's keeping track of everything. I need to hit this pretty hard, actually, to make it trip. But what's going to happen when I get to 20, if I can get to 20? There we go. The circuit is now open. Can you see? Now, open sounds good, but actually it's not. That means that nothing's happening, basically. It means that the circuit is broken. That's what I would have said. And they went blue, right? So when I load the customers, I get failure, and then now it's gone into a mode where it's lost tolerance for failures. As soon as there's a failure, it's going to go to the fallback. The blue is the fallback, all right? So it's falling back every time. And it's not going to the fallback via the attempt. It's not even attempting to get to the stores. It's going, okay, stores not available, fine, I'll just do whatever I used to do. And when I do that, you did notice already probably, but the map doesn't have any stores on it anymore. So that's a business decision, right? The customer's app is able to degrade gracefully. What's powerful about this is the nice algorithms and the reporting and monitoring that's built into Hystrix. So that's just a flavor, really, of what we have been doing with Spring Cloud. And if you want more, give us good feedback and come to our presentation tomorrow, basically. So I can go back to the slides, actually, because there are some presentations that I want to highlight, as well as just a slide or two. So for want of a better umbrella term for those things that I just showed you, those were, I don't know, maybe 3 or 4 of the cloud components that we've been working on, Spencer and I. So the idea then, to recap, is that we've identified some common features of distributed systems. They're boilerplate, and we want developers to be able to build them really simply, just as Spring Boot apps. That means they're configurable, they're customizable, they always do something sensible, convention over configuration, but they're extensible. They have opinions, but they're not going to get in the way if you want to do it your own way. Also, as I've shown you, actually that's the thing I didn't show you. I didn't tell you where the URL was on Cloud Foundry. There's a Cloud Foundry PWS deployment of all that stuff. Yeah, ask in the lounge or catch me later and I'll show you that. customersui.cfapps.io, if anybody can remember that, just type it in and enter yourself and see it working. So the key thing, one of the key objectives for us is to be able to do what I just did, right? And it's a little bit awkward to have to start 5 things up every time I want to work on one of them, but at least I can do it, right? And as I showed you, I think at the beginning, the customer's UI started up fine. It didn't actually need all of that other stuff around it. It was going to work. So there's some goals to achieve to make the experience of bringing up a system as painless as possible and working on isolated parts of it as painless as possible. And to make it easy to migrate from that, from like a developer box experience to deploying on bare metal in a data center or in Cloud Foundry or whatever. So if you want to learn more, I brought up a little bit of this stuff, well, last night and also today in my security talk. Tomorrow, Spencer and I, it's not 12:30, it's 2:30, it's 12:45. No, that's Ramnivas. Simplify Cloud Applications. Ramnivas at 12:45. Spring Cloud, Spring Boot, and Netflix OSS. I think the times are wrong because we changed them, didn't we, Peter?
Yes.
Yeah, I don't know. I don't remember which way it went. Check the schedule online. Those are the sessions. Ramnivas is the first one. Spencer and I are doing Spring Cloud and Netflix, and the microservices pass is Matt Stein, I believe. So you'll see bits of this in various places there. So with that, I'm going to wish you all a good night. Have a drink, buy me one, if you feel like it. And my job isn't yet done, by the way. I've got another session tomorrow, as you can see. customersui.cfapps.io. Yeah, go and have a look at it. And then what we're going to do now is show you another part of a system like this one, basically, using almost the same domain, but using some different technology. And John's going to tell us all about this really exciting reactive stream stuff.
All right. I'm John Brisbin. Thanks. Thanks for being here still. If your bladders are anything like mine, I know you're getting ready to get out of here. I'm not going to take up a lot of time. I'm going to get right to it. If I'm a little bit over the top sometimes, you'll have to I apologize ahead of time because I'm actually pretty passionate about some of this stuff. But I guess that's just how it is. I'm going to do the demo first because I don't agree with Mark that if it's not a good demo if something doesn't go wrong. So I hope this is actually everything works like it's supposed to. But let me check it out first before I send everybody there. And I'll give you an idea of kind of how, the intent behind the demo. So basically, what I wanted to do to illustrate what we're talking about with some of this async stuff is mix in a little live data, mix in some geo data, and I'll blow this up in a second so you can see what I'm doing. But I'm going to enter some information in here, and this would be kind of like maybe if you're in a mobile app and you have a check-in or something like that. And I'm going to say I'm at the Omni Hotel here in Dallas, great state of Texas. And I'm gonna update my information. Now, are we on network here? Are we flip another one? And I'm gonna say I'm a bum and I'm living at Union Station. Okay, so what we're seeing are some updates, and if you notice, like what I just did was I had two separate inputs of information from separate ones. So if you want to go to geocoder.cfapps.io, it's a responsive app. You can pull it up on your phone. You should be able to enter information. Kind of the idea is you put your name in and your company, and you put your home address in there, and then when you hit your update, then it should as other people are entering their information, or you could do this one as well if you wanted to maybe show up on our little. What happened to my? Let's go over this one maybe. Somebody else wants to put in Dallas, Texas in their information, and we should maybe, there's Stefan down here. Give him a hand, he's French, yes. But it's kind of deceptive though, because it seems like it's incredibly simple. I mean, we've got a nice little HTML form, and we've got some more people in here. There we go. Okay, yes, okay, good. So we've established that we're getting WebSocket updates. Now, how are we doing this? In a traditional application, you'd probably have to apply a fair amount of code to to achieve something like this, because there are certain things you have to worry about, and you have to asynchronous web and all these things that are sometimes just ridiculously hard to keep track of, for especially for teams that are not terribly familiar with the domain. So we actually are going to show you real quick out on GitHub. This is the source code for the demo app, and there's not a lot to it. It's a boot app. So as with everything else in this conference, we're using a boot app. There's a few HTML component. There's a JavaScript component, and I'm using Rave.js as a module loader. John Hand and Brian Cavalier were helping me out earlier today, getting this lined out. It's using Cujo tools. It's super cool. Nothing complicated as far as that goes, though. But if we look at our Java code, as you've seen before with like any Spring Boot application, you have like this central point, this bootstrap point, and that's your application class. So let's just take a little. I know that you can't really see this, but I want to show you the size of it first. Okay, so here's all the code that we've got, right? There's some code there, and there's a little bit of helper code down here. So there's not actually a whole lot. And don't worry about like trying to figure out what all this stuff does. This is Rat Pack code, a lot of it. The post and the promise and the then. Come to our session, we'll explain that in a lot more detail. But just suffice it to say that what we're doing is wiring up a web app, and we're creating a REST endpoint for post, and we're going to parse our JSON, and then we're going to do this method call, this here locations.create, and then we're chaining things off the end of it. Without getting into a whole lot of detail, I'm going to show you what's behind that, but just for the time being, know that that's an async call. It happens in another thread than the Rat Pack thread. That's the whole reason for the promise then stuff. And the consume is handled for you. The result is passed from one thing to the next. I mean, just think about, just right there, one statement and two method calls, and we've got a whole lot of things actually happening to handle async results and task execution and thread management, things that you would normally have to have a fair amount of infrastructure to handle, and an understanding of concurrency programming and all these other things that we really have absolutely no idea what we're doing, even though we tell the boss, hey, yeah, sure, we can do that. I promise it'll be done. And other things that that we continue on. And this one is even actually a little more interesting, because we're calling our service method, which is returning a stream, and I'll show you that in a second. It's like we have to in this particular app, we can't do blocking I/O on the thread that's serving this, because I'll kind of talk about it a little bit, and what's blocking, what's non-blocking, if you're not familiar with it. But basically, I'm using, under the covers here, I'm using Spring Data repositories, and the driver is essentially a blocking. It's essentially a blocking call, because it's waiting on a result. It calls a method and expects a return value coming back, and we have to push that off onto another thread so that all of our scheduling will be efficient, and we can share resources as much as possible, and that the HTTP server can go back to serving other clients. You don't want to tie up an HTTP serving thread waiting on results from your database if you're trying to do super high volumes and keep it efficient. You need to let those I/O threads do what they do, which is read data from the client and send data to the client. And so we're going to segregate that off into and we're going to return a stream, which in our case, in Reactor's case, means I'm going to go do something, and I'll let you know when I get the result. And then you can chain actions off of that. You can do map and flat map and filter, and there's way more stuff than we can really get into and what is a stream as far as Reactor is concerned, but just know in a few operations here, I've linked together streams and substreams. I've created with the flat map, I'm calling another service method that also returns a stream, which I'm returning up, and so it's like this, it's like this labyrinth of streams that are going one to another, but it's only a few lines of code, and it's a single statement. You don't have to get terribly complicated to get all that, functionality. So let's jump over to the service class that I was telling you about real quick. So that was the little bit of that. That was mostly just chaining and HTTP stuff. There wasn't. I mean, there was only basically like 2 service calls in there in a single bean method, right? So that there's not a lot there that's required. We have a location service class, and that the HTTP API was calling. Essentially, they're calling this this update method, and I mean, we can't get into a lot of the details, so if you see something up here and it's like, I don't really get what that's doing, come to the session on Thursday and we'll explain it all. But basically, the dispatcher is, you would use a thread pool, or a dispatcher does kind of precisely what it implies, in that it takes a task and it schedules it, but it does it in a super efficient way, because we're using the ring buffer, and we've spent an ungodly number of hours trying to profile this and send out these, numbers and everything, and the team has always given me a hard time about the numbers and, millions per second, blah, 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 whatever. But it's trust me, it's fast, it's efficient. There have been applications running for weeks at a time with 0 GC. I mean, that's the kind of thing you want if you're serving like lots and lots and lots of requests. So the dispatcher is, we've got a bunch of these in our environment, and we're just load balancing them across the application. So any task that needs to be executed could just grab one of these load balance dispatchers and execute arbitrary tasks on them. And that's very similar to dispatching onto a task scheduler or a thread pool or something else. But if you think about dispatching into a thread pool, there's always a question of, okay, now what? Okay, once you've run it on another thread, what do you do with the result? How do you get it back to where it needs to be so that the next action can take place? Well, if you don't have a library to help you do that, and something like RxJava is really good at that because it's observable, and then you can also mix in dispatching. Reactor takes a little bit different approach, but it's essentially the same type of thing. Is the library takes care of all these little operations for you. So rather than setting up a bunch of method calls in a very imperative way, we use a very functional approach. And we create this stream, and that's another, you've heard this word like a lot. Streams this, streams that, microservices this, and that's something that Reactor is going to help you deal with. And then when I talk about reactive streams, then we're even talking about a larger ecosystem than that. But essentially a stream is like what I said, it's a way to wire actions together, and you not have to worry about, oh, well, this is operating synchronously, this is operating in this thread, this is operating in another thread. You call these methods and pass your functional components in them that will respond, react, if you will, since we want to keep the reactive paradigm. And you can issue blocking calls, like in this map, I say location save. That's a Spring Data repository method call. I'm not doing any other wrapping of that. I'm calling the repository method directly, but that's happening in a worker thread, so that I don't have to worry about the conflict between blocking in my HTTP server and loading from a database. But then as soon as that's done, I'm handing it off asynchronously, not concurrently, but asynchronously into the next one, which says essentially what this is saying is there's another stream out there called location save events, and I'm broadcasting the save event that I just got to some other place. And there are other streams that are descended from that common stream that are listening to those events. So I'm doing a broadcast, an event broadcast. I'm using it as an event bus, if you will, but I'm doing it in a single line. And you see the double colons, that's Java 8's method reference stuff. Super cool. If you're not using Java 8, you should. If you can't, then you need to tell your boss, hey, this is what I'm doing, or I'm going to quit. Okay, so look at lambdas. I mean, isn't that totally awesome? Just with the little arrow. I mean, I know groovy guys are going, we've had that forever, and whatever. But I'm a Java guy. I was originally a COBOL guy, and then Java, and this stuff is, I mean, that's awesome. You can do it in one line of code. But basically, what I'm doing is I'm doing a transformation. I'm doing it in non-blocking, in memory, doesn't require any I/O. I'm taking as input my object that's come out of the database after saving, which is MongoDB in this case, and I'm creating this thing called a predicate. And so in this particular instance, and again we'll talk about it later, but I'm actually running a formula that's like calculus, and I'm not a math guy, so I have no idea what it actually does. I just copied it off the internet, but it basically tells you how far away two points are from each other. So I mean, Wikipedia to the to the rescue. But I put that in the predicate, and I'm passing that on to the next stage in the filtering chain, and then this is kind of where it gets. This is where it gets like, hold on to the back of your head because it might explode. I'm doing substreams in here, and I'm merging historical data and live data. So I've got this location events thing, and like everybody, when you were updating on that form and that stuff was coming in, your updates were going into the shared stream. And what I was doing in this particular one, when I pulled up one, and the same thing happened for you when you pulled up your page, is I went in and created my own specific filtered substream just for events that I care about. So I was initially getting all events, but because of that predicate, I said filter out any that are outside of the distance that I care about. Now we didn't really get into, we could get a more sophisticated on Thursday and actually do different geolocations, and you'll be able to see people that enter addresses and things in one geolocation that are farther than 20 kilometers away from another will only see ones in their area. But basically that's what's happening here, is that I'm doing a very dynamic substream type thing. And then the nearby streams.put at the end of that, that's basically just caching it for later, so that when I open my WebSocket connection to the nearby URL that's specific to this particular document ID, then I'm actually attaching directly to the stream, and I'm only going to be getting events coming out of it that pass my filter predicate and everything. So again, let me show you the size of this. I mean, that took a fair amount a fair bit to explain, and there's a whole lot going on here, and that's a single freaking statement. That's one statement, and I just built a live WebSocket app that includes historical data, live data, filtering, task scheduling on separate threads. Yeah, totally cool. So let's go to the slides now. Do I just hit the green button? So one of the things that we really need to pay attention to this in these sessions, and we're hitting over the head with this, is this idea of services, and particularly microservices, because just about everything that you've seen demoed tonight, in every way, is some kind of a construction of multiple microservices. And I mean, we could argue about the taxonomy of it, and what's a microservice, what's a nano service, what's a traditional just plain service, because it's not micro or whatever. I mean, all of that is really pretty academic. But the idea behind it is that there are specific boundaries that you're creating, and they're fairly restricted. So you're creating a service, but it has boundaries around it that you use to compartmentalize things, because these resources are not cheap. That things are not free, even though they may give away a free year or whatever. Amazon, when you're done with that and you actually want to use a real server, then you realize that things are decidedly not cheap to do this sort of thing. So you need to be able to compartmentalize, and that's what Spring XD and the stuff that Dave was just showing are allowing you to create these modular components, microservices, if you want to call them whatever name you want to use, because they need to be more efficient. They need to do their particular thing, and they need to do it the most efficient way possible. Utilize resources that are relatively expensive and as efficiently as possible to save you money. There's a direct correlation between required resources for microservices, the number of them that come out, and your bottom line, and having to pay for the infrastructure to run them. So you've seen the word streams, you've seen the word service. We're talking about Reactor here, and I've mentioned this idea of reactive programming, and I don't know how many of you are familiar with or have even heard this term bandied about, and it's it's nothing that any one company can claim to. We can't claim it. TypeSafe can't claim it. Whoever wants to write a paper and put reactive in the term, I mean, they're not planting a flag on anything. This has been around for a long time, but it's essentially has characteristics that have developed over the years of being event-driven, being modular, like we talked about. Microservices are very modular, scalable in that you can bring up many of them. They're highly available in the sense that you can have multiple copies of these things around and be able to load balance between them. And then there's probably the most important thing as far as reactive programming goes, which is different than your traditional microservice programming, which is this idea of blocking versus non-blocking. And I talked a little bit about how in the HTTP server, if you're doing I/O, and I/O is a good example of non versus blocking, is that you can't tie up a thread when you have very few of them on the system to use. And typically in a non-blocking application, you would have maybe one thread per CPU, or one thread or 2 threads per CPU maybe, but a very small number, not hundreds certainly. That these things have to be managed very, very efficiently, which you can't do if you're grabbing one of them and holding on to it until you wait for a response from another component. And if you're going to do that, then that opens up the problem of how do I communicate between these tasks? How do I pass, since I'm not waiting on a result, where do I put the result and how do I notify the next component that it's available? And that's where the functional aspect comes in. And you saw in the stream, I was able to chain a bunch of calls together and create a single statement that does half a dozen different things in a very, very succinct, a single method. Which is not going to be difficult for most people to understand, being able to just read the code, as opposed to most of our code, which is probably very not understandable, especially to the people that come along behind us. I've got a good story about that I'll tell you on Thursday about a guy that was intentionally obfuscating code because he didn't want the guy to come along behind him to know what was going on. So, but microservices and being broken up into these small components they're a perfect fit for this reactive architecture. Because they have boundaries that have to be crossed, and there's overlap, and these things about that keeps coming up is what do I do with results when I have them, and how do I schedule things on other tasks? That's perfect for your microservice architecture, to have a reactive architecture that responds to stimuli rather than having a publisher in charge that has a big list of things, and and you've got your service underneath, and it says, oh, I'm going to give you these whether you can handle them or not, and your service just has to sit there and say, thank you, sir, may I have another, for every piece of data that's coming in. It's not always asynchronous. I mean, I should say it's asynchronous, but it's not always concurrent. Those are two different things. An asynchronous action can be concurrent, but it doesn't have to be. If you think about a JavaScript event loop, very simple. Things get scheduled on an event loop. It's a single thread, so it's not concurrent. It's asynchronous. Things get delayed, deferred, if you want to use the term. And pointing to the non-blocking versus blocking, and the ability to, since we have boundaries, then we can isolate things, and that's good for resource utilization. That's good for handling failure. But there, admittedly, if you start getting too many of these things, then the reactive architectures can be fairly complex, and for many end users, more complex than will actually pay off. And that is where Reactor and some of these other initiatives are trying to come to help and say, oh, we know that there is this architectural pattern that we need to support, and the way that we're going to do that is through this term called stream that we've talked about. Now, this little animation, it's kind of cute. I don't know. I wanted to have, you have to have a PowerPoint presentation with an animation in it. There's no point in having PowerPoint if you don't have an animation in it. So this is the requisite one. But the idea is pretty simple. Each of these microservices generates things. It goes through a task queue. It goes to other microservices, or whatever term you want to use. But it's managed then by the library. So real quick. Reactive streams then, so we've talked about reactive architectures. Well, there's an additional component to this ecosystem in that some of the guys from TypeSafe and some of these other places got with us and others in the community, and you can see the list here, and they proposed that we create a standard, and it's essentially a specification. And by specification, I mean not some arcane legal document that you can't understand. It's a conversation about how two components should interact with each other in a way that is very advantageous for asynchronous systems. And we don't have time to get into the specifics of it, but know that Reactive Streams is a community effort to enable reactive architectures in a way that is extremely efficient. One of the things it does that's unique is it inverts the relationship between the publisher and the subscriber. So instead of the publisher being the imperative one that says, you must take the task that I give you, the subscriber says to the publisher, give me the next however many I can handle, and that number that it can handle is based on your resource utilization and the RAM in your machine and the how backed up your queue is, and any of these other heuristics that you decide of how many tasks you can handle at a time. Then your subscriber says, give me the next 12 or whatever that number happens to be, and that number correlates to the exact amount of resources you have available. It's not too many, it's not too little, it's just right. It has an additional, this interaction that I talked about, the inversion, is basically what we would call back pressure. So right now, back pressure, if you have a slow consumer, is basically blocking, right? It says, well, you can't even send me anything. I'm going to stop your processing until you can send me something. And so the idea behind Reactive Streams, and one of the things that was really kind of hammered in at the beginning of the proposal, was how do we create this so that it's all asynchronous, that we can communicate back pressure from one component up through a whole chain of asynchronous actions until the original producer at the very beginning of the stream send me the next one. You have to have a specification in place that explains how this interaction works and explains what the responsibilities are of the publisher and what the responsibilities are of the subscriber, and that's what the specification does. And then Reactor goes to the next step in that we implement the latest version of the Reactive Streams specification, and that coincidentally allows us to interoperate with other Reactive Streams implementations through the shared API, the publisher-subscriber subscription API, which comes from the artifacts provided by the Reactive Streams project. But it's not just interop. I mean, it is nice to be able, if you remember back to my streams.merge call, where I was merging historical and live data in, the live data could very easily have been an Akka Streams implementation or an RxJava observable, who will also implement they'll have a layer that connects Reactive Streams into RxJava, and you could do that transparently. In fact, Ratpack, the web library that I was using, built on Netty, also uses the Reactive Streams API. So if there's a few little things about it, so it's early in the implementation, so I couldn't really demo it here tonight. But at some point in the very near future, you should be able to connect directly a Reactor Stream into a WebSocket in a single line. You just say WebSocket broadcast, you give it the context, and then you say, here's the Reactor Stream. And so anything that comes in on that stream goes right out to the WebSocket, and it's managed underneath in the way that Reactive Streams is meant to govern this relationship. So a couple interesting things of real practical application of streaming reactive processing is Stuart's presentation, and I don't know, he put 1 million events per second. I mean, I don't know. We can do many more than that. Whether it'll happen in the demo, who knows? But the point is that it's a lot. Okay, we could have just said a lot of events per second, right? It's more than you would traditionally do in any other type of architecture. And we'll be talking about the same type of thing then in Stefan and I's presentation on Thursday morning, first thing, coffee, our session, and talking about Reactive Streams, Reactor, and how those relationships work between the API and the specification and Reactor with the library, and then how Reactor integrates with some of these other tools, or will integrate in the future in some cases. So that is Reactive, Reactive Streams, Reactor. That's a very umbrella term, but anyway, come to our session on Thursday and you'll learn a whole lot more than I could give you in just a few minutes. And who's next? Peter? We're good? We can go drink? Hey, let's go. That's what I've been waiting for.